In this activity, we'll be creating a program that utilizes the IMPL keyword to create functionality implementations on structs and enumerations. Once you're ready, let's hop into VS Code. Open up your activities directory and navigate to A12. We're on activity 12, so double click. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. As we can see, this topic is about implementing functionality using the IMPL keyword. Our program requirements indicate that we must print out the characteristics of a shipping box. We have to include dimensions, weight, and color. In our notes, we can see that we need to use a struct to encapsulate the box characteristics. We need to use an enumeration for the box color. And we need to implement functionality on the box struct to create a new box. We also need to implement functionality on the box struct to print the characteristics of the box. So we'll be able to use functions, however, they have to be done as implementations on our structure. I'm going to start by copying in some notes into the program. So first, I'll create the enum for the box color. So we use the enum keyword, color. It doesn't indicate how many colors we need, so I'll just have the typical brown box, and I'll have a red box for fun. Next, we need a struct to encapsulate the box characteristics. So we use the struct keyword. I'm going to call mine shipping box, and we need the color. We also need dimensions and weight. As we can see here, we need dimensions, weight, and color. So the weight can be an F64. And for the dimensions, I'm going to actually make another struct. So for the dimensions, we'll have another structure called dimensions. And that will have a width. And we'll set that to an F64. We will also have a height and a depth. Next, we need to implement functionality on the struct to create a new box. So we'll copy both of these in. I'll create the implementation block using the IMPL keyword, and we're going to implement functionality onto our shipping box. So we're going to create a new box first. So we'll have new. Current naming conventions in Rust indicate that we should use the new function when we're implementing functionality to create a new structure or enumeration. So I'm naming my function new. It's going to accept a weight as an F64. It will accept a color, and it will accept dimensions. I will then use the self keyword to return a shipping box, and we'll create the shipping box using self with the weight, color, dimensions. So the self keyword always refers to whatever you're implementing. So this refers to a shipping box for both of these selves. The fields here have the exact same names as the actual structure, so I don't need to indicate which field I'm referring to. So I don't need to put in color and then set it to the color variable. So that doesn't need to be done because if you have the exact same names as the struct fields, then it'll automatically put the data into the correct locations for you. Now, before I implement the functionality to print out the characteristics of the box, I'm actually going to implement functionality on the dimensions and color data. For the color, I'm going to implement a function to print out the color. So I'm going to use the IMPL keyword and the name of my enumeration. I'm going to call this just print. It's going to take a reference to self. It won't return any data, and it's just going to print out the color. So I'll match on self. And if we have a color of brown, we will just print out brown. And if we have color of red, we'll print out red. In this implementation block, we're simply borrowing self, which is a color that was created somewhere else. We're matching on the color. There's only two variants available. So we have color brown and color red. I'm also going to be implementing functionality onto the dimension structure in order to print out the dimensions. So I type in the IMPL keyword, followed by the name of the struct, which is dimensions. And then I'm going to create the same function name as I did on color. And it's also going to be a reference to self. So again, we have a function implemented on dimensions. The ampersand followed by a lowercase self indicates that we're referring to a dimensions that has been created elsewhere. I'm going to place a series of print line macros that display the information as needed, along with the debug tokens. So for this one, we have the width, where you can access self, which is a dimensions. Dimensions has 3 fields. I'm referring to specifically the width field for this print line statement. We then just need to deal with the height and the depth. So we'll change this one to height. And then the next one will be depth. And now we have a function implemented on dimensions, which prints out all the information needed to display a dimensions structure. Now that I've implemented that functionality, I can go back to the shipping box and actually print out all the information. To do so, I'm going to create another function called print. And it, again, is going to take a reference to self. And then I'm just going to call self.color.print. Now here we have a reference to self, which is a shipping box. Within that shipping box, we're accessing the color field. And then within this color field, we're accessing the print function. So let me split the view and we can see how it looks. So this is a color within the shipping box. And then we're accessing the .print function within that color. So we're accessing this function to print out whether it's brown or red. Next, I'm going to print out the dimensions. So I'll do self.dimensions.print. And that's the same thing as the color. So referring to self, which is a shipping box right here, we are accessing the dimensions field here. The dimensions field is a dimensions type. And if we look at our implementation of dimensions, we can see we have a print function. So this .print refers to this print function, which will then print out the width, height, and depth of the dimensions. Lastly, we want to print out the weight. So I'm just going to do a print line, and we'll have weight with the debug token again, self.weight. So on this one, we have self, which is a shipping box, and we are referring specifically to the weight of the box, which is right here as an F64 field. Now that the implementation is completed, all we need to do is create a new box, and then we can print it out and see what happens. In order to create a new box, we first need to set the dimensions. So we'll create a small box, we'll call this small dimensions. So we have dimensions, and we have a width, and that can be 1.0. We have a height, and that could be 2.0. And we have a depth, and we'll set that to 3.0. Always end your let bindings with a semicolon. Here we're creating a dimensions. As we can see in this dimension struct, it has 3 fields, and we have our 3 fields there. We will then create a new box. So we'll call our shipping box small box, and that is a shipping box. I'm going to use the new function that we implemented on the shipping box to create the shipping box. So instead of just creating the structure directly like I did with the dimensions, I'm going to use this function to create it instead. So we have shipping box, and we call the new function. I'm going to pass in a weight of 5.0. The color can be red, and the dimensions will be the small dimensions that we created. As you can see, we have our small box. We access the shipping box information, the implementation block here. We call the new function by using the 2 colons new. Function calls are always in parentheses. Our function has a weight, a color, and a dimensions. And here we have our weight, our color, and our dimensions. So our dimensions were created here as small dimensions. That will go right there. And finally, now that we created our box, we can actually print out the information. So if we call smallbox.print, our information should all print out. Remember, we have a reference to self here in our print function. So we can use the .print notation on the variable small box. I'm now going to run this program. So to run the program, go to Terminal, New Terminal. We are on activity 12. So you can type in cargo run -q -bin A12. So here's our information up here. We have our width, height, and depth of 1, 2, and 3. We have a red box and its weight is 5.0. So as long as everything's coded properly, we should have that information displayed to the terminal when we run the program. So let's give it a go. As we can see, we have a red box. Its width is 1, its height is 2, its depth is 3. So that looks good. And then our weight is 5.0, as we can see here. I'm going to do one last walkthrough of the entire code so we can see exactly how it works. I'm going to split the view so we can see all the code at the same time. All right, so we're creating first a small dimensions. We're creating a new dimension structure with a width, height, and depth of 1. We are then creating a small box variable using the shipping box new functionality. This functionality is implemented here on our shipping box. We call the function with 5 for the weight, red for the color, and then for the dimensions, we use the small dimensions that was just created here. That will be the dimensions. We use the self keyword to refer to this shipping box, and then we create a new shipping box using the weight, color, and dimensions that were supplied down here in the main function. We then call smallbox.print. .print is provided by creating a function implementation using a reference to self. So self refers to a shipping box, and since we have the ampersand, that means it's referring to a shipping box created somewhere else. In this case, it was created right here on the previous line. In this print function, we use self.color. Remember that self is a shipping box, and as we can see here, a shipping box has a field named color. So when we do .color, we access this color enumeration. So this color enumeration is up here, and it has its own implementation of print. So here on the left, we're accessing color.print, which is this function here. We then refer to self with an ampersand, which is a color. And that means we have a color created somewhere else, which was created when we made our new shipping box. We then match on the color. We have two variants, brown and red. We account for all of them, and then we just print out whether it's brown or red. After that prints, we return back to our print function in the shipping box, and then we access the shipping box dot dimensions. So the dimensions are here, and that is a dimensions structure. The dimensions structure has 3 fields, and it also has an implementation of its own version of the print function. We access the print function in the dimensions by having a reference to self, which refers to a dimensions created elsewhere. Again, that was created here in our new, which was initially created right here. We then print out self.width. So self is dimensions, and it has a width, height, and depth. We print out the width, height, and depth. Control then returns back over here to our print function. Finally, we just print out the weight, referring to self.weight. This self refers to shipping box, which has a weight field of F64. So we access it using .weight. Finally, control then returns to the end of the main function and the program terminates. My implementation of the activity may seem slightly convoluted with the arrows going everywhere, but this is how you'll see most of the code out in the wild. And in order to write maintainable code, this is normally how you would want to do it. You can encapsulate different pieces of information and then in turn implement functionality within those pieces quite easily. If we were to implement all the functionality just on a shipping box, things can start to become complicated later on. But if we do it this way, where everything is a small piece, where we have a small color, small dimensions, and then our box, everything composes together nicely and is isolated. So later on, when you want to make changes to, let's say, the color, all you need to do is just change information here. And the rest of your program, you can just ignore it because everything's encapsulated in this thing. As well, same thing with dimensions. So all of our dimension information is handled right here. We don't got to worry about the shipping box, and we don't have to worry about the color either. And of course, the same thing with the shipping box. All the shipping box information is here and here. So we don't need to worry about our colors. We don't need to worry about our dimensions. All we need to know is we can access our color.print and our dimensions.print. And that's the only thing that actually goes outside of the shipping box itself. And this is just a good practice for code organization. Just break everything up into really small pieces and then compose it all together into one working program. This concludes the activity video. I'll see you in the next presentation.